Hi guys, I'm going to go over some of the assignments that have been placed in Google Classroom. I've had a few questions from some of you, so I figured it would be better if I just went through and did a demonstration of sample problems. So this is a periodic table that is currently located in your Google Classroom, and I've wrote notes on it. I have rewrote these notes numerous times, helping students and doing Google Meets or reteaching the remote kids that have returned to class. So it looks like this if you open it up in Google Classroom. It's located down in your periodic table topic. So you just have to scroll down a bit, to previous assignments. So things that are on here, and from the last video that was posted, I went over these things with you, is you have your valence electrons, which are going to be in blue across the periodic table, and then with the last group being full. And then with red, I have notated what their ionic charge is going to be. And the ionic charge is going to be based on if it gives or takes electrons. And we know that the fewer that it has in its valence level, that it's more likely to give electrons, and the more that it has in its valence level, it's more likely to take. So the first assignment that I'm going to go over in your classroom, if you were under the ion and isotope topic, just as a reminder to make sure that everybody's doing this properly, you should always be starting at the top and working your way down. So these assignments right here were just practice things, just getting some background information and then doing a doodle note. This is the first real assignment where you have to do work figuring out the ions and isotopes. So that is what this assignment is right here. So I'm going to do a few samples with you. So for this top part up here, one of the things about this is talking about an atom. So your protons and electrons will be equal to each other, because this isn't talking about an ion yet. The thing that might change in this is you're going to have some isotopes, and with an isotope, the mass will be different. It's going to be different from the mass that's on the periodic table, and that's going to end up making your neutrons different. So that's the only thing that changes is the mass number, and therefore the neutrons changing. So if you notice on here that it gives you a mass, don't go to the periodic table and get the mass. Use the one that's indicated for you. So like this one gives you a mass, this one gives you a mass. Here you have a mass. You have neutrons and electrons are equal to protons for this particular one. So you could add these two up to get your mass. So for this first one up here, we had carbon, and how this is set up, what it tells us is this number that's on top, this is your atomic mass, and the number that's on bottom is your atomic number. Okay, so from the things that we know about this is if we know the atomic number, or we know the number of protons, it doesn't matter which one we start with, we know electrons here, and we know the atomic number. So for this first half of this assignment, all three of these things are going to be equal to each other. So that's where the 6 gave us that information. The 14 was our mass number, but then in order to get neutrons, we just go 14 minus 6, and that gave us 8. Over here, we are diagramming electrons, okay? So that's the particle that'll be diagrammed. So we had 6 electrons, so we know from the rules of Bohr diagramming that 2 can go in your first orbital, and the second orbital is not full until 8. So once I put the first 2, I have 4 left, and they go on the second orbital. Well, electron configuration is just how many is on each orbital, starting at the centermost. And the first one's always going to be 2, and then the next one you would count how many is there. If it's full, you know it's 8, but this one we had 2, then 4. So what I'm going to do now is I'm going to go ahead and do this first one with you guys. And the first one thing we would want is silicon symbol. So if I go to the periodic table, silicon's located right here, and it has a symbol of Si, and its atomic number is 14. So I'm going to go back over here, and I'm going to put in Si. And we already have its mass because it gives us a mass right here. So I'm going to put that number for the mass. And then its atomic number was 14. So I'm going to put that right there. So as I told you before, that atomic number is going to tell us protons, electrons, and atomic number. So I'm going to go ahead and put that down for all of those. 14. Oh, I accidentally clicked on the wrong thing. Sorry. 14. So now we've got to get our neutron count, and if we go 29 minus 14, that's going to equal 15. So the next thing to do would be to diagram our electrons. And my suggestion is to use your drawing tool on like a 2-stroke thickness. So we have 14 electrons. So you don't have to draw these arrows. I'm just doing this to help with the note taking. So the first orbital can only hold 2 electrons. So I'm going to go 1, 2. The second orbital can hold 8, and 8 plus 2 is 10. So I'm going to go ahead and put all 10 of those. So currently I'm going to have 10 electrons diagrammed, but I have 14. So that means I need 4 more on the outer orbital. So now at this time, I've got to do my electron configuration. And electron configuration is going to be starting at the centermost orbital, how many electrons. So we have 2 on the first orbital, we have 8 on the second orbital, and we have 4 on the outer orbital. So that's how you would do your electron configuration for that. I'm going to go ahead and scroll down, and I'm going to do a demonstration of these about ions. So I'm also going to put a note up here at the top that says this is a charged atom, and what's going to happen is it is going to give or take electrons. So our electron count is going to change for this. And we can use these charges that we placed above the groups, and knowing that hydrogen varies from the other elements in this group because of the fact that it only has 1 orbital, unlike the others. So this one was already done for you, and it's going to be the same, steps as you took before, other than the fact of electrons changing. So we know that aluminum, it has a mass of 27, its atomic number is 13. So our protons would be 13. We would get neutrons by going 27 minus 13. Electrons came from the charge. So this is the thing that you've got to realize, is that if you have a positive charge, what happened is you gave 3 electrons away. That you're going to do the opposite. If you see a positive charge, you're going to subtract electrons. Because if we go to the periodic table, we can see aluminum is in this group right here. So aluminum, when we would diagram it with a atomic number of 13, if we did its electrons as an atom, it would have 2 on the first level, 8 on the second level, and 3 on the third level. Well, 3 being on the outer level, that level wouldn't be full until 8, which means that it would need 5 more to get full, and it's not going to be able to get 5. So the way for it to become or to be, not to be an ion and be ready to share and bond with something, is that it's going to give electrons away. So if it gives electrons away, it's going to have 3 more protons than it does electrons, meaning it'll have a 3 positive charge. Okay, and its atomic number is that of the protons. That's the one thing that never ever changes, is your number of protons, because that's the number that identifies it on the periodic table. So then when we diagram the electrons, you only have 10. So you'd have 2 on the first orbital and 8 on the second. And something to know about when you're diagramming the ions is that its outermost valence level will always be full, because that's the goal of when it's becoming an ion, is for its outer level to be full. So we're going to do this next one together. So this element is calcium, and its symbol is Ca. And calcium has a mass of 40. I just know that from looking right here. But I could go to the periodic table and get that as well. And just to show you, calcium's atomic number is 20. And see, there was its mass of 40. So its atomic number is going to be 20. So that atomic number tells me how many protons I have. So I'm going to go ahead and put my protons down. And I can go ahead and put that here as well. So I've got that taken care of. So we'll go ahead and do our neutron count. So we go 20 or 40 minus 20, and that would equal to 20. And then our electrons. So what we've got to look at this is we've got to go look at the periodic table and let's look and see what group calcium's in. So it's in group 2. And we identified that group 2 is going to have an ion charge of 2 positive because these elements are all going to have 2 valence in their outer shell, meaning that they would need 6 more to get full. So they're just going to give the 2 away in their outer, meaning that they have 2 more protons than electrons. So calcium's charge is going to be 2 positive. So what that is going to mean is that it's going to have 2 more protons than it does electrons. So that means I need to subtract 2 from this in order to know my electrons. So if I'm going to have 2 more protons, we'll have 20 protons. Well, 2 less than that would be 18. So my electron count will be 18. So when I go over here to diagram my electrons, I have 18 electrons, so the first orbital will have 2. The second orbital is full at 8, and I'll need all 8 because those 8 plus 2 is 10. And so I'm at 10, and my electron count is 18, so I need this orbital to be 18. So as I said, this is going to be full. And as an ion, they will always have a full outer valence because their goal was to get full by giving or taking electrons. So its electron configuration will be 288. For this next one, I'm going to go ahead and do this one with you as well. This is chlorine, and it just has a minus sign there. And what that means, there's going to be numerous times when we're doing problems, especially this first semester, that you're going to see a plus or a minus, and it doesn't have a number. If it doesn't have a number, that means it's just an understood 1. So if you wanted to put a 1 there, you could, but it's not really necessary because it's just giving you the charge. So this element is chlorine. I already have its mass and its atomic number here. So with the atomic number, I can go and fill in its protons, and I can fill in its atomic number. And I have its mass. Its mass was right there at 37. So I can go ahead and put that down also. And electrons. So for this one, if it has a minus charge, what that means is that it took an electron. So if we go look at the periodic table where chlorine is, it's in group 7 or group 17. And at group 17, it has 7 valence electrons, so it only needs 1 electron to get full. So it's going to end up taking an electron. So if it adds an electron to its count, it had 17 protons, so it will have 18 electrons. So look at this. They're going to have the same ionic diagram because they both have 18 valence electrons. So that means the first orbital will have 2, and then the second orbital is going to have 8. So it looks the exact same as calcium's diagram, but that's because they're ionic diagrams, and ionic diagrams are always going to have a full outer valence. And so they either gave or took electrons in order to become full. So there's quite a few elements that would end up with an electron diagram looking like that as an ion. I want to say something about hydrogen real quick, which is your next one, and then I'm going to go ahead and move on. So hydrogen, if we go to the periodic table and look at hydrogen, hydrogen has an atomic number of 1 and a mass of 1. So it's going to be a little bit different than the other elements that are in that same group. So we know that its protons is 1. We know that its atomic number is 1. To get its neutrons, we still have to go mass minus atomic number, which its neutrons would end up being 0, because on the periodic table itself, hydrogen doesn't have a 0. But as an isotope, it can. So for this one, the reason why I want to point out here is that hydrogen is in group 1, and most of group 1 is a +1. They give an electron away, but that's because all of these elements have 2 or more orbitals, and those orbitals aren't full until they have 8 on them. And so if they only have 1 valence, they would need 7 to get full. But hydrogen doesn't fit the rules of group 1, other than the fact that it has 1 valence. It's a nonmetal, and these are all metals. But hydrogen with only 1 proton and 1 electron means that it just has 1 orbital. And the first orbital is full with 2 electrons on it. So hydrogen is going to take an electron so that it can fill its outermost orbital. So hydrogen is going to have a 1 minus charge. So what's going to happen to it is, with a minus charge, remember that means it took an electron, because you're doing the opposite of what the charge is. So that means you're going to have added an electron to it. So it'll have 1 more electron than it does proton. So its electron diagram is going to look like this, and it's going to have 2 on it. So then that means that its electron configuration would be 2. All right, I'm going to go back just real quick and go through just a couple of other things with you guys about some of the other assignments. I'm not going to really go through a whole lot. For this assignment right here, you're going to have some of those transition metals. And by transition metals, I'm referring to these right here. And with a transition metal, the thing about them is when they indicate what they are, you're going to have like Fe, which is iron, which is located right here. And past iron, how it would tell you what its valence number is by Roman numerals. So you're going to see like iron like that with 3 Roman numerals, which would mean iron 3. And if you saw that, that means that that iron is going to have a 3 positive charge. But you could also see iron, and it could be like this. It could have a Roman numeral 2. And if it had a Roman numeral 2, then it would just be a 2 positive. So these are all going to be metals. And your metals make up like the majority of the periodic table. They're like from here over, except for hydrogen. Remember, hydrogen's a nonmetal, but the majority of this periodic table is made up of metals, and metals tend to be cations. So they're going to have positive charges. So with that assignment right here, I made you a note explaining that so that you would know. And then also I had suggested that if you are unsure about knowing metals and nonmetals, you can always go open up a periodic table, like type periodic table with metals and nonmetals, and it'll have them color-coded so that you can find that easier. This atom builder lab, one of the things to know about it, it's only slides 2 through 10. There are some blank slides on the end of it, but one of the things about it, just to make sure that you're doing, is that on the second slide, you have to open up an exterior website. And that's the only place you can open it is from right here. It'll mention it numerous times, but it's going to take you to a PhET simulation. And the PhET simulation is where you will practice building atoms. And the things that you're going to be looking for as you do this is like which particle makes an atom get a name. If you put an electron on here, does it get a name? No. If you put a neutron on here, does it get a name? No, because those are not particles that identify the element. When you put a proton on there, now it has a name. And then we're looking, what causes it to get a charge? Well, look, it just got a charge because now I only have one proton and I have two electrons. The other thing is when it wants to know about stability, you would have to click that, and stability is going to be determined by the neutrons. So it became unstable with two, but it was stable with one, and you could play around with different bits of that. There is a game in this that it wants you to play, and you are supposed to screenshot your score and post it in there. So just, making sure that you're aware where those things are, you just click down at the bottom to go to the different parts of it. Periodic table and reactivity. This is just another little assignment, nothing majorly different. Ions versus isotopes. This is just for this one. It goes through what a cation and anion is again. You will diagram it as an atom. You'll diagram it as an ion, and then you'll go through this. I could do one of these with you guys real quick for those of you that want to stay on the video long enough to see this. So for this part of it, if we were going to diagram, if we were using lithium, I could go to my periodic table and I know that lithium has an atomic number 3 and its mass would be 7 because it's 6.9. So its atomic number is 3. It has a mass of 7. So if it's an atom, we know that its protons and electrons are equal to each other. So it has 3 protons and 3 electrons. To get neutrons, I have to go mass minus atomic number. So 7 minus 3, that would give me 4 for its mass. So I could go ahead and go over here and diagram its atom. So it has 3 protons. So 1, 2, 3. And you might want to make those lines a little bit bigger for this one because the lines on here are a good bit bigger. So you might want to go up to like a 4 so that those electrons show up a little bit better. So when we go over here, I'm going to come back to this in just a minute. When we go over here and we're talking about an ion, remember that the thing that's going to change for an ion is going to be its electrons. So electrons are what changed. And it's based on its charge. And we can get that from the periodic table. So everything else will stay the same from the other side. The only thing that's going to change is going to be the electron. So I can go ahead and fill in everything else. Okay, so it's electrons. So let's go to that periodic table. So lithium is in group 1, and it's one of the elements that has a second orbital. And because it has a second orbital and it has a valence of 1, that means it would need 7 to get full. And that's not going to happen, so it's going to give its outer one away, giving it a 1 plus charge. So it's going to have a 1 plus charge. Well, I wasn't supposed to put that there. That's the next thing. Its number of electrons would be 1 less. So it'll have 2 electrons because it gave 1 away. And then its charge is a 1 plus. And then over here, all you're doing is it a cation or anion? And cation means it's positive, anion means it's negative. So I do need to go back over here and diagram my ion real quick. And it only has 2 electrons as an ion, because remember, as an ion, it always is going to be full. So that's how you would do that particular assignment. This assignment right here, this one right here, I deleted, and I don't think I deleted it out of your class, so let me delete that real quick. that assignment ended up being messed up. It got sent out wrong. So this is just one where you're identifying the reactivity. And just to go over a couple things about reactivity, it's going to have you make predictions of about what elements might bond together. And things to look for would be like, say, if these elements right here, I want to give one electron away, isn't there a group on the periodic table that would want to take an electron? This group right here is a -1, means it takes an electron. So group 1 and group 17 are reactive to each other. And reactivity is based on like what its charge is. The ones like this group right here is the most reactive group in the periodic table because of the fact that they only have that one valence electron, and they really want to get rid of that one valence electron so that they can have a full outer level. These would still be highly reactive, but not quite as reactive as these because they have two, and they're going to have to give both of those away. But look at this, there's a group over here that wants to. So these are just predictions about things that would bond together. Of course, other elements bond together. They don't always bond in perfect matches, like, fluorine bonding to lithium. Like they can bond in many different ways. And we'll look at that when we actually start talking about compounds and making molecules. But for this particular lesson, it's just wanting you to make some predictions about it. And then this last assignment that I have in here, there's a sample for you, so you should be able to just follow exactly what it gives you here and do these little writing bubbles about the elements. And you'll open this with Cami just like you do other things, and you'll be able to type in it. You need to make sure that you're using these words when you do this. And another thing just to be helpful about it is to know that you're going to have to count your electrons to know what element it is. So this element right here, it had 7 electrons. So I knew that I would know this right here is going to be nitrogen. So this one right here, it has 3 electrons, so that's lithium. So we can't really read its nucleus fully. I can see that one a little bit better, but this one right here, I have no idea what its nucleus is. So I'm going to have to count its electrons to know what it is. So that's how you'll know what these elements are in order to write about them. And just, like I said, just follow this one right here as an example. So one last thing I want to go through is that I did go ahead and I am going to be putting in here, this was not supposed to say quiz, it's supposed to say quiz review, but there's going to be some review games that are going to be posted right up here, and those are going to be for people who have already finished all of these lessons about the ions and the isotopes. So you need to make sure you finished everything. Once you've finished everything, then you can go do your review, and then I am going to post the quiz here. Do not take the quiz until you've completed all the assignments and you felt good about your review. If you have any questions, all you've got to do is email me, and I'll get with you if we need to do a Google Meet or whatever in order to help with your understanding prior to taking the quiz. So I'm going to go ahead and end this video now. If you have any additional questions, please let me know.